Hello, I'm Michele from messautomation.com, and today we see how to make a C# application to communicate with a Siemens S7 PLC. We will use TIA Portal V13 and a PLC S7 1200. To do this communication we use the driver S7.net that is open source and you can find on GitHub. The official website for S7.net is on GitHub. You can see it here. Here you find the sources and you find also the documentation. I already downloaded the documentation. It's a PDF. You can check it here. To use the protocol with the new PLC of Siemens, the 1200 and the 1500, we need to be sure that we uncheck the optimized block access on the DB, and we also have to check on the PLC the protection and permit access with put get. I will show you right now. So on the DB we go on properties, and here we have attributes, and we have to uncheck this. This is checked by default, so we have to remember to check this, to uncheck this. And on the PLC we go on device configuration, we go on properties, and then on the bottom here we will find protection, and on protection on the bottom we will find permit access. We have to check this. This is unchecked by default. Okay, once you have checked this, you will see on the data block that you will have this structure that will give you the offset and accessible and visible from the HMI. Also on the program you will see this address that has absolute address with db1.dbx 0.0, 0.1 and so on. These addresses are standard if you already see the old step 7 with version 5. With this address we can read from C# the value of data block. So let's get started with our application. We will use a console application, so there will be now user interface and other complicated things. Okay, we have to download the S7.net from Nugget, manage Nugget packages, and we install. We go on browse, you search for S7.net, you click on S7.net Plus, and you click install, and basically it installs the version. Then we can now use the program. So here I create my PLC, it needs some data. Okay, with this data I'm basically creating my CPU, and here I'm connecting to the CPU. I'm using the simulator, the PLC sim, as you can see right now, and also I'm using net2plc sim, so it's already running. I can show you the configuration. I can show you how to configure this. So we can just create a PLC, we can give the address of the network that we want to connect. It's localhost actually, and here with PLC sim IP address we can just browse and double click and we can go. On slot depends on what PLC we use, but we have the default on S7300 and we have the default for 1200 and 1500 that is always 01. So okay, we have to do start server, so we see running. Then because we know rack and slot is 0 and 1, the network address is the PLC address and the type we know it. So we now go read the first data block. To read the first data block I will copy and paste some code. Okay, this code reads the first bit and the second bit and will output the value on the console. They are both false. Because if I go online I will see that they are false, so I expect that they will output true false. Okay, so let's read the other values and I will copy and paste some code again. Okay. So now we are going to read various types of data. We are going to read integer, real, double integer, double word and word. So let's go back to our program. Let's start the program. And let's check the values. Okay, as you can see the 50 is correct. Then this number should be 25.36. So we miss a conversion here. These three numbers are correct with these three. So okay, this is, we just need a conversion for the real number. Let's look how we can do this. So S7.net offers some method to convert to double, and this is 1. And actually we have the correct format. You can notice there is a minor error on the lowest decimal because of the conversion from floating point to double. Okay, so I added also a timer. You can see it here. A difference from step 7 to TIA portal is that you can add the structure of the timer to a data block. So what we are interested in is the elapsed time, and to read this you can just read the integer on dbd26. Let's look how we can do it. So this is the code that we are interested in. We basically read dbd26, and it says 10,000. So here it says 10 seconds, so it seems that they are milliseconds. Let's verify if they are correct. Let's start the timer. This is a T-off, so it will start when I turn down this contact. So I go to 0, the timer starts, then I start my software, my program. This says 4.21 milliseconds. So 4 seconds dot 21 milliseconds. Okay, so this is how to read the timer. We can also read the db3. Okay, as you can notice, I put all negative values here on db3. So let's see if we can read db3 with the same code that we were using for db1. So let's start the program. And as you can see, we have all negative values, but here it's more clear. This is not correct, and also the others are not correct. I should have all negative values here, but here I see that they are positive. So this means we need conversions also on the numbers when they are int or double integer or double word or word. On integer and double integer you must use conversion. On words you usually intend to use hexadecimal values. If you use words for integer numbers, then you need a conversion too. So let's see how we can convert these numbers. It's very simple. It's the same as here for convert to double. You can just wrap, so, and we can say convert to short. So we have unsigned short. S7.net will offer a method to convert to short. Also for unsigned int, we can choose for convert to double or convert to int. This is an integer. Again. And again. So in this case we use words negative, so we are going to convert them. This is a word, so it's convert to short. Let's start the program, and now we see that the numbers are corrected. We can do the same thing for db1, and now let's check the numbers, and they are still corrected. So this is how it works to read single variables and to convert them. Now this is working, but this is not optimized, because what happens when we make a read? So we are creating a TCP package and we send it to the PLC, and the PLC has to reply with the value that we need. So this is really not the best way to read variables. So let's see if there is another way. We can read all the bytes in one shot from db1. So plc.read, we can see there is read bytes, and it requests data type, the db, the start byte address, and the count of the bytes that we have to read. Let's use. Okay, bytes count, we have to see how long is our db. So db1 is 34 plus a real, so we need 38 bytes starting from 0. So we need the bytes. So let's see if this works. Okay, we read 38 bytes, and as you can see, our array contains all the bytes. Now, with these bytes, how can we convert from bytes to our variables? And let's see what we have here. So we read all the bytes of db1, and then I take the first byte at address 0, and I select the bit 0, and I have the first bool. And again, for the second bool, dbx 0.1, I take the first byte and I select the first bit, and here is my variable. Okay, for the double integer value, I use the S7.net.types converters. So S7.net.types, as you can see, has a series of classes that matches the classes of TIA portal. So we have byte, counter, double integer, double word, word, and so on. So okay, this is the byte that we are going to read. So this starts from the offset 2. So we have to skip the first 2 bytes because our byte starts from offset 2. Then we take 2 bytes and we go to array, and the from byte array, it converts from an array of bytes to our short data. And for example, we can also see the next one, double from byte array. Again, I say skip 4 because it starts from 4. Then I take 4 because it's 4 bytes, the double, it's a DBD, and to array. And again, for DBD8, skip 8, so I start from the address 8 and take 4 until 11, so DBD12, and so on. Let's see the output. Okay, it's correct. So let's see if we can do the same thing for DB3. Here is the code. So we read data block, we change the address to 3. Again, we start from 0. This time we have 18 here because data block 3, it's 16 plus it's a word, it's 2 bytes, so it's 18. So we just execute it, and here we have our values already converted. Now we don't have negative numbers here, and we don't have because we use the word and word. So what we have, it's an unsigned integer and an unsigned short. So what's the difference between this method of reading bytes and this method of reading single variables? So here to read 16 variables, I need to make 16 reads to the PLC. Here I just need one request for DB1 and one request for DB3. So is there a simple way to read all this data from the PLC? Yes, there are. a simple way, and it is by using classes. This has some limitation. For example, it can't handle strings, but let's see how it works. So we create a class. We say let's create a class. We create a class db1. This class must match the structure of db1. So let's take the code of db1. Let's show how we match this. Okay, so this is db1. I have two boolean variables, then we have to complete the 2 bytes, because here we have 2 bytes. So we have 2 boolean, then we have nothing more until 2, but we have to complete the structure with 3 bytes. This is an integer variable, a double real variable, and so on. Okay, what's interesting is we have this timer one, that is 1, 2, and 3 double words. Then we have the timer 1 bytes, and then we go back on a real, that is static 1. Once we have this class, and we can read our class in one shot, so we just create an instance of the class, and we read the class. So this is db1, then on db1, and start address we use 0. So let's see how it works. And as you can see, we have all the data that are written in the integer variable, real variables, and so on. And to output the data, we just need to do this. The first variable. Okay, so we can do the same with db3. We just have to create the class. Then I can just copy and paste the first structure, and then we can read db3. So we just copy and paste several code. We just have to change it here and here. Then we read class db3 free, and then we just add. And again, here is our db3. So the last thing that I want to talk about is how to read multiple variables in one request. What if we want to read the bytes on db1 and the bytes on db3 in the same request? Okay, S7.NET also offers this possibility, and is done by read multiple vars. Okay, this takes in input a list of data items. So let's see how we can build this list of data items. Let's paste some code. Basically, I create a list of data items, and that contains 2 data items. One says that I want to read the db1 38 bytes, and the second one says that I want to read the db3 for 18 bytes. Now to read the data items, I can just say read multiple vars and data items. Then when this method reads the values, it will put the values that it reads inside the data item.values. Okay, so same as before, db1 bytes are data items.0.value. We have to cast as byte, and db3 is data items.1. So let's print these values and let's see if they work. We can just copy and paste from read bytes. So let's launch the program. I do one request and I get all my values. So this is a nice feature to be used but it has some limitation. As you can read from the description, we cannot read more than 20 data items, and we cannot ask more than 200 bytes plus 22 of header. This is because of protocol restriction. Now that it is clear how to read values from the PLC, let's see how we can write values to the PLC. We can use two ways. So we can specify the absolute address of a variable, or we can just specify the block of bytes that we want to write. So let's start with writing by specifying the address. Let me paste some code. We use plc.write, then we specify the address and we specify the value. When we have to write integer or double integer and everything, we have to convert every time to unsigned int or unsigned short before writing. To verify that we write correctly, let's reset the DB. To reset the DB, I just create two empty bytes and I write them on DB1 and on DB3. I will use write bytes instruction and I specify the data block, the DB1, and I send a array of bytes of 18 bytes. So as you can see now, on DB1 I have some value here, on DB3 I have some value. I will reset them. Okay, so here I have 0 and also here I have 0. So let's okay, this is the code. We're going to write 50, 25, 36 and so on DB1. Then on DB3 we are going to write -50, all negative values. As you can see, I convert to u short to u to unsigned short to unsigned integer before writing. And okay, let's just start the program. And as you can see, we wrote correct values here and here negative values. So this is how we can write a single variable. So how can we write a block of bytes? To write a block of bytes, we can do like this. Here is the code, and we create a byte of, in this case, I have to write DB1 18 bytes. Then for booleans, I take the byte and I set the bit that I want. In this case, because I want to set it true, we can use set or clear. They take the buffer and they take the index of the bit, and clear puts the bit to 0 and set puts the bit to 1, and get value returns the value. So because we want to write to true, we use set. So this is for the bits. And then for shorts, again, we use the conversion that is on s7.net.types.integer. We call to byte array, so from a short value we receive an array of bytes. With this array of bytes we copy to our buffer that we are going to write, and starting from index 2, because the variable is db1.dbw2. To write the real value variable, we use the converter from s7.net.types double. We write 2 byte array. The bytes we copy in db1 bytes starting from index 4, and so on with the double integer, with the word, and with word. Here we just say plc.write bytes on the db1 starting from 0 all the buffer. So this writes consecutive bytes, and the same is for db3 with negative values. So as we did before, let's clear the data. Okay, let's execute the program. And here we have 0 and 0. And now let's run the program. And here we have our values. And also here we have the values. So this is all what we need to know to use S7.NET. The last thing that I want to talk is the error handling. So there are two properties that we can use for errors. One is last error code and the other one is last error string. And there is a method that says clear last error. So how to check if we can open the connection, for example. Okay, we can just check the error and we can say if result is not error code dot no error. We can, for example, say right line okay. How we can test this? Let's stop the server and let's try to connect. We got a result connection error, and then it will go and last error code is connection error and last error string there is the error. Let's restart the server. Okay, this is also every override function returns an error like this. Let's see the definition. So all the override functions returns an error code, that is this error code. And also open returns an error code. Now, about read, what happens if we have a read error? Okay, if we have a read error, we probably have some problems with cast. But how can we check the errors for a read? Okay, let's take, for example, to read a single variable. I want to read db10.dbx0.0. Now, okay, let's check what happens. So here I write read single variable, and let's jump into it. Okay, here we make the read, and we have an error, invalid cast exception. So we can investigate here, and it says wrong var format and the variable could not be read. Please check the syntax and try again. So in this case of invalid cast exception, when we are doing a read, you can also check these two properties and get the error. So this is the end of the video. Hope you enjoyed it. S7.NET is a free library. You can use it, you can modify it and sell it. You can just download the sources. You can also contribute to it. You can send pull requests. We accept pull requests. Also, if you like the video, subscribe and put a like on the video. And if you have comments or questions, you can write the questions here on the comments, or you can also write on my website. You can find all the link in the description. So see you on the next video. Bye.